Dijkstra's algorithm helps us find the shortest path from a starting node to all other nodes in a weighted graph, but it only works when all wedge edge weights are non-negative. Think of it like finding the fastest route from your house to every other place in your city. Let's understand how it works step by step. We start at the source node. In this example, it is 0, and set its distance to 0 and all others to be infinity. And next step, we use a priority queue of pair, that is distance comma node, in which we always pick the node with the smallest known distance, so hence a min heap. And for each neighbor we update the distance if going through the current node is shorter. To get the shortest distance we use this formula, and we repeat this until all nodes are visited or we have found all the shortest path. To understand it better, let's walk through this example. In this example we have 5 nodes from 0 to 4, and source node is 0. So we start at the source node and go to the edge nodes that are 1, 3 and 4. So let's say we are going from 0 to 1. What we see is the distance of 0 plus weight, that is 5, which is less than infinity. So we will update the distance of 1 to be 5. Let's write it here, 5, and we will update the priority queue to be 5 distance with node 1, and we will pop this 0, 0. We'll go to the another node, that is 3, and again we'll update to a distance 9 with node 3 and again node 4 with distance 1. And now we will pick the node from the priority queue with the shortest distance. So the shortest distance is 1, so we will go to the 1. So now we'll check for the 4. From 4 we can go to the 3. And when we go to 3, what we see is the distance from 4 to 3 is 2, plus distance from 0 to 4 is 1, and what we see is 2 plus 1 is 9, that is 9 is the distance of 3. So what we will do is we will update the distance of 3 to be from 9 to 3, and we will update this distance to be 3, and we will pop this node 4. Hence the visited nodes are 0 and 4. Now we will go to another shortest distance, that is 3, 3, as 3 is updated. So we'll go to the 3, 3. Node is 3 and distance is 3. From node 3 where we can go is 2. So here we will check the check distance of u, that is 3, plus weight is 6. 3 plus 6 is distance of 2, that is infinity. So what we will do is we will update the distance of 2, that is 3 plus 6 9, and we will update the priority queue to be 9, 2, and we will pop this node. And now we will go to the to pick another node with shortest distance, and here what we see is 5, 1. So 5, 1, the node is 1. From 1 where we can go? We can go to only 2. We can go to 0 as we pop the 0. So when we go to 0, what we see is distance of 1, that is 5, plus weight, that is 2, which this is less than 9. So what we do is we update the distance of 2 to be 7 and we pop 5 comma 1 and we update here 7. So now we again go to pick the node with shortest distance, that is 7 comma 2, but when we go to the node 2 we see all other nodes are already visited. 3 is already visited, 2 is already visited, so we just pop this node and we get our final distances as 0 to be 0, 1 to be 5, 2 to be 7, 3 to be 3 and 4 to be 1. Hence this is an efficient algorithm to find the shortest distance from the source node. Thank you.